Hey everyone, welcome to another libGDX tutorials. In this video, I'll show you how to develop this explosion particle effects in libGDX, and it only takes a few lines of code within a few minutes. This effect uses one of my pixel space invaded game. You can see it here. When an alien is destroyed, it explodes into many particles with random colors. This video also has a written tutorial on my website, so if you prefer reading the text, check out the link in the description below. So why bothering making custom particle effect at all? There are two major advantages of using a dynamic particle effect versus a handmade sprite animation. Number one is flexibility. Unlike static animation, you can easily change the effect strength, color, intensity, speed, and effect size because all the parameters are dynamic and the effect variables are computed at runtime. And number two is small footprint. You only need a few hundreds bytes to store the effect sprites compared to hundreds of kilobytes or megabytes of handmade animations. So before we start writing the code, let's design the particle sprite first using a web app called Pisco. Go to spicoapp.com, click the Create Sprite button to make a new sprite. First of all, let's adjust the canvas size to be 8 by 8 pixels. Then select the pen tool and select the white colors as the primary color. Draw a small square in the canvas center. Now let's add a new frame and draw a small cross at the center. See the preview window in these top right corners. In just a few seconds, we only have a tiny explosion particle animation using only 2 frames. Now let's export and download the project as a zip file. Use particle underscore for the prefix. Let's check out the algorithm to animate a particle in libGDX first. An explosion effect is initialized at a center position, which is also the starting point for every particle. Each particle has its own states, which are updated on every frame. The states contain the current position of the particle, initially at the center and moving toward the target position. The target position is the final destination of the particle. Also the size or the dimensions of the particle, and the local rotation angle of the particle. The target position, the size, and the local angle of all particles are pre-calculated when an explosion is created. For each frame, we update the particle current position and move it closer to the target position. Then we draw on the particles with their updated states. In the implementations, we declare a few constants for our particle effect. The particle count is the total number of particles that will be emitted when the effect is triggered. The particle radius is the maximum distance that a particle can travel from the effect center position. The particle speed is how fast a particle can move to its destination. And finally, the particle size specifies the maximum size of each particle. This particle class includes all the details which are discussed above. This reset method calculates the particle target position using trigonometry with some random values for direction, angle, and radius. We also need to create an explosion class to generate a collection of particles with some default states in the beginning. In the constructor, we initialize a fixed number of particles and pick a random colors for them. A set position method is used to set the explosion centers, then pre-calculates on the particle states around that position. For every frame in the explosion class, we iterate over the list of the particles to update its positions and draw them to the screen. We also update the explosion alpha values until it becomes 0. Then we stop the animation and return it to the pool. Aside from the explosion class random method, the main class random method manages the states of all explosion instances. It detects and initializes explosion instances at a touch position. Then it iterates over the list of explosions to render each one of them. Every time an instance expires, it goes back to the object pool to be freely available again for the next acquiring. And that's the full implementation of the explosion effect. The effect is also highly customizable because you can easily change many parameters to modify the look and feel of the effect at runtime. Here I'm making several changes and assign arbitrary values to the total number of particles, the radius, the speed, and the size of each particle to create all kinds of new effects. You can even develop a firework effect on top of this by implementing logic to pull the particle down after some conditions. Check out this tutorial on my website on how to further extend the effect so it becomes a firework. And that's all for today. I hope you enjoyed these videos. See you next time.